So in this problem, a food department is kept at negative 12 degrees Celsius by a refrigerator in an environment at 30 degrees Celsius. The total heat gain to the food department is estimated to be 3,300 kilojoules per hour, and the heat rejection in the condenser is 4,800 kilojoules per hour. So determine the power input to the compressor in kilowatts and the coefficient of performance of the refrigerator. So first, this is the figure for this problem. We have here the warm environment at pH or high temperature, which is 30 degrees Celsius, and our TL or in low temperature, which is negative 12 degrees Celsius, and this is our refrigerator. So this is the QH or the heat transfer to the high temperature, and this is our QL or the heat transfer to the low temperature, and this is our rate of work input. So now let us solve for the work or the rate of work input. So this is the formula. Rate of work input is equal to the rate of heat transfer to the high temperature minus the rate of heat transfer to the low temperature. So plug in the values. We have for our rate of heat transfer to the high temperature of 4,800 kilojoules per hour minus 3,300 kilojoules per hour for the rate of heat transfer to the low temperature. So plugging it in our calculator, we have 1,500 kilojoules per hour. Since we are finding the answer in kilowatts, so we have to multiply it by 1 kilowatts over 3,600 kilojoules per hour. So the final answer for this is 0.417 kilowatts. Next, we have to find for the COP or the coefficient of performance of the refrigerator. So this is given by the rate of heat transfer in low temperature over the rate of work input. Since we have the value for the rate of work input, let us just input it in our equation. So for the QL or the rate of heat transfer to low temperature, we have 3,300 kilojoules per hour, and for our net or the rate of work input, we have 1,500 kilojoules per hour. So plugging it again in our calculator, we get the answer for the coefficient of performance to be 2.2.